Welcome to another confidence interval example. So in this example, a study was run to estimate the proportion of US college students who work during the school year. A random sample of 100 students was found to have 74 who worked. Find the 95% confidence interval for the proportion. So key things we're doing here, we are trying to estimate the proportion. So estimate tells us that we are likely doing a confidence interval. We also have that it's a 95% confidence interval here. We're working with proportions, so we're working with a p-hat distribution. So we know that we are doing a confidence interval, specifically a 95% confidence interval. We are working with the p-hat distribution. We have a random sample, which is good. We need a random sample, and it has 100 students. So we have it as a random sample. That's from the whole population. We know that our sample size N is 100. And then of those 100, 74 worked. So we are looking at p-hat. We have 74 worked out of our 100. So we are looking at a proportion of 0.74 for our sample proportion. From here, we have to justify running the confidence interval. We had two key things. First up, we need a good sampling technique. And second, we need to have our normal distribution conditions. So we need to check that we have a good sampling technique. So it's random. And we also have it draws from the whole population. So we meet our base conditions for a good sampling technique. Then we need the normality of the p-hat distribution. So we have to check that n times p, although in this case we'll use p-hat, and n times 1 minus p, again, p-hat, are both at least 10. But we can also simply check that we have essentially at least 10 or more yeses and 10 or more nos. So the number of yeses, we had 74 who were. Number of no's, we are looking at 100 minus 74, or the remaining 26 students. So these are both 10 or more. Again, we can only do this when we have a confidence interval because we don't actually know P. We're doing an approximation. For hypothesis tests, we would have an assumed P, and then we just do n times P and n times 1 minus P. So from here, let me give myself just slightly more space. And then we can write our sentence. So we can find the confidence interval. Or it's fair to find the confidence interval because the sampling technique was good. And the conditions were met. For a normality of the p-hat distribution. So we're allowed to find the confidence interval in this case. Then from here, we need to understand our sampling distribution. So we know that we are working with the p-hat distribution. For the shape, we know it's normal, as we saw in step 2. For the center, we don't know. This is what we are trying to estimate. Right? It's mu sub p-hat is p, and that's what we are trying to estimate. And then for our spread, we can get a good approximation. Sigma sub p-hat is approximately the square root of p-hat times 1 minus p-hat over n. So it's approximately the square root of 0.74 times 1 minus 0.74 divided by 100. And if we do that calculation, we wind up getting approximately 0.044 for our standard deviation or standard error. From here, we need to find our confidence interval based off of the sample. So the first thing we need is our point estimate or the base estimate. This is our sample statistic. So we have p-hat is 0.74. That's our base estimate. Then we need to give ourselves some wiggle room. So we find our margin of error, our wiggle room. For 95% confidence, it took approximately 2 standard deviations out from the mean to have 95% of the data. More precisely, it was 1.96 standard deviations. So for 95% confidence, the margin of error, I'm going to label ME for margin of error, is 1.96 copies of sigma sub p-hat. That 1.96 is always the value we use when we're looking for 95% confidence. So we are looking at our margin of error is 1.96 times 0.74. And sorry, not 0.74, 1.96 times our standard deviation, which was 0.044. If we do that, we wind up getting approximately 0.086 or 0.09. This is our margin of error, that's our wiggle room. When we find our confidence interval, we start off at our p hat. So this is our p hat, or 0.74. We go out by our margin of error. So we're going to go up by 0.086, and we go down by our margin of error. So we're going to go down by 0.086. This top one becomes 0.826. And on the bottom, we should have 0.654, if I did my arithmetic correctly. So our confidence interval winds up being 0.654 is less than P is less than 0.826. From here, we have to explain the results of our study. So our generic sentence is the researchers are, or we are. So we are 95% confident that the proportion of US college students who work during the school year falls between 0.654 and 0.826. If we want to explain this in a way that maybe would make more sense to people that have never studied statistics, we could also say we estimate that between 65.4% and 82.6% of US college students work during the school year. And the method used to run the study is expected to yield accurate results 95% of the time. So the first sentence I wrote before my squiggly arrow is sort of our generic statistics version. And then these last two sentences is what we might, or how we can explain this to the general public. So this method is expected to yield accurate results 95% of the time, meaning when we go to pick our sample, there's a 5% chance that we pick a non-representative sample. So when we pick our sample, there is a 5% chance of picking a sample which is not representative of the population. Or representative enough of the population. All right, that is my example.